So I'm going to put two links in the chat right now. This first link is to download the R base package. So R is an application that you can download onto your system. It is an open source data analytics specific application. And because it's open source, it is extremely comprehensive. It's peer reviewed. It's free, which is great. And it's widely used within specifically the research and sciences communities because of those reasons, especially within the educational sector. In research institutions, it can be expensive to have every single student, every single employee have access to a proprietary system, but having an open source system like R lets people have access to something that's really powerful, but also inexpensive. So when you go to this link here, you're gonna see, actually, I'll start sharing my screen so you can see this. You're going to see a list that looks like this. And when you see this list, what you want to do is you want to find the country that you're in. So I would scroll down to the United States, and you'll see that there's a lot of options still in here. Because the system is open source, there's a lot of branching that happens. So not all of these applications are the exact same. I tend to use this one down here, the National Institute for Computational Sciences, because they have a really robust package, but you can use any one of these, and based on what that institution focuses on, you may see that there's more. So for example, I think I saw on here, Carnegie Mellon University. So you may see at Carnegie Mellon, there may be a focus on healthcare, or there may be a focus on behavioral economics. And because of that, some of the code base may be a little bit different than, say, the Hubley classifieds in Pittsburgh. So again, I like to use this National Institute for Computational Sciences. And then just download this and execute the program once it's downloaded, and then you'll be ready to start the next download. So for the next one, I am going to have you download Rstudio. And what Rstudio is a code editor that has a much more user-friendly front end that allows you to work with R as opposed to just doing a raw code environment. So once you download that, just pick your OS, so your operating system based on Mac or Windows or Linux, and then execute that program. Doran, I see that you are going to follow along for the day. Anyone else who is interested in, who is actually going to be following along with us as we execute code, please do the little hand raise reaction now, and then I'll put your hands down so I can just keep track. And then after I put your hand down, let me put your hand back up as soon as you have Rstudio installed on your machine. In the meantime, I just wanted to do a quick poll and kind of get your thoughts on here in R, we can do a significant amount of both qualitative and quantitative data analysis. We can bring in survey results and do an understanding and an analysis on survey results. I wanted to hear from all of you. What are your thoughts on qualitative versus quantitative data collection? Which is better? Which do you think gives more insight into a problem? Are there situations in which some are better than the other?
I feel like depending on the industry or like the use case. I know for like science stuff, I feel like people have a huge focus on quantitative information, but I think there's a lot that's valuable in qualitative, even though sometimes it's harder to, I guess, like visualize.
Yeah, I feel the same way. I think we put a lot of focus on quantitative results, but ultimately those qualitative results can be just as fruitful and give a different story and perspective than the quantitative results do. Does anyone else have any other thoughts on that? Okay. And I will take from the lack of hands that everyone will be following along for now, and then just listening in and then doing the code and everything afterwards. So I'll just move along as if that's the case, and feel free to jump in and stop me if you have questions, if you want me to slow down, anything like that. Okay. So today we're going to walk through R, and what we're going to do is walk through Rstudio. Um, so uh, so Rstudio is a point and click directory that is also a code-based directory for us to work in our data. So the way that you find Rstudio is just through your search menu. I would recommend, if you have any sort of security, that didn't work. If you have any sort of security on your computer, to open your Rstudio application as an administrator. And what that'll allow you to do is install solutions into Rstudio. It'll allow you to write into file paths. So for example, if you're writing your data out at the end, it'll allow you to read in files without having any security blockers. Based on what folder you're using, or if you're trying to access an API or something. It just makes things a little bit easier, as long as you're extremely comfortable with the sources that you're getting your data from and all of the installations that you're doing. If you do have concerns about that, obviously run as a user, and then if you hit blockers, assess those as they come up and determine whether or not to override your security. So what we're going to do today is we're going to install a number of packages. We're going to call those libraries into our system. We're going to do a few really basic pieces of code just to kind of explore the IDE here. And then we're going to make some charts and graphs. So the first thing that you want to do once you have R installed and you have Rstudio open is you want to install some packages. We're going to be using a bunch of data science packages. So we're using this one here is called SF. We're using Tidyverse. Tidyverse is great for using data frames. Cleaning data, making things a little bit tidier. We're going to use Leaflet, which can be used for really nice graphics. SP is a spatial data package that's nice to have on here. I don't believe we actually use it today, but it's always nice to have installed. RODBC is a way for us to read data in from online. And Read Excel brings Excel data into our system. NannyR allows us to do some data manipulation. And then Ggplot2 is how we're going to graph some of this data. So one thing about installing packages is once the package is installed on your system, you don't ever have to install it again unless you get a new system, you set up a new environment, etc. However, every single time you start a new R instance, you need to invoke those packages. So these libraries have to be called. So, for example, I have these installed on my computer already. To run code within R is Control-Enter. And what this will tell me, likely, is that I already have these binary packages. So these already exist on my computer. I downloaded all of these earlier today, but what you're going to want to do is you can either highlight these and install them all at once, or if you go to a single line and hit Control-Enter, it will install one package at a time as you run each line of code. So the next thing we want to do is invoke all of these libraries. And so by hitting Control-Enter again, now I'm invoking each of these libraries. Now we can use all of these packages within the system that we have here. So R is it's a readable, use case based code language. And by that I mean it's read, left to right, and it's very straightforward. So for example, if we decide to create a variable called x, then this is x is equal to the string hello world, we can enter here, and when we call x, we get hello world written into our console down here. So it's just going to output hello world every time we write x. I can write it down here in our console directly as well. And it just says hello world every single time. So now instead of in an algorithm writing out hello world, you can write x and hello world will pop up. We can do the same thing with vectors. So we just did this with a string and assigned it to a variable. We can assign a vector to a variable. So a vector is created by using a C with rounded parentheses, and we can create a vector of the numbers 1 through 10. You'll see that your global environment is set up here in your upper right-hand quadrant. And what this does is it will track all of your variables within your environment as you continue to build out. So now we see we just created a vector of the integers 1 through 10 listed as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now if we go down here and we call v again, we'll get those numbers, even though we very quickly just made this 1 through 10. And we can do that for any amount of numbers. So we could do b is equal to the vector 5 through 75. And then we can call b. And note up here that it lists the amount of numbers within this vector, but the values that we're seeing are 5 through 75. So here you'll see the amount of integers, whereas the values will be listed as the values you identify for your vector. The next thing we can create is a list. So these are all just different types of groupings of data within R. So a list is unlike a vector, a list is often made of strings and has a few other different ways that it can work within the within analysis. So you can identify whether you want to use a vector or a list based on your use case. So we can create a list of these strings, and when we run L, we get a list of dog, cat, bird, and squirrel. One of the ways that I want to point out the use case is you see here, these are actually listed, they're listed vertically, whereas the vectors were listed horizontally. So keep that in mind as we go through the next few pieces. The fact that these are listed vertically is important in the next few pieces of code that we run. So this is our list animals. One thing we can do, because it's a list and listed vertically in that way, we can find things within that list. So I can look for the string dog in animals. Maybe. Oh, there we go. Okay. Oh, right, because in animals we get a vector. So apologies. So we have a list, but to do these other analyses, we do need to have these listed as a vector. So what we can do is we can find dog within our vector. So we want to use the string dog in animals, and here down in our console, you'll see it lists as true. So what this is saying is dog exists in animals. Obviously here we can just go and look at our vector of animals and see that dog exists. But imagine if we had a vector of 10,000 strings. We can also look for fish, and it gives us a false. So that also gives us the opportunity to find what isn't in the list. Then finally, what we can do is a match function. And what this will do is identify the number of instances in which dog is listed in the vector of animals. So essentially what the match function is what you would use as the count function in Excel. Are there any questions on this first set of data analysis that we've gone through? Okay, cool. So that's a very simple introduction to the world of R and the things that we do. The next thing we're going to do is, so we're going to remove everything from our environment. So we see that we have all of this data up here in our environment. I'm going to run this piece of code here, remove list is equal to ls parentheses. By running that empties our environment up here. And that's just nice to keep things clean and tidy, especially if you're in the middle of writing a piece of code and you want to go and test it out from the top again. You don't want to be accidentally using old variables or anything like that. So removing everything is really helpful. Excuse me. So the next thing we're going to do is we're going to be pulling data in from our computers. There are two ways to do this. You can do this through code by setting your working directory, or you can do this in your session, so through point and click, set working directory and choose your directory. And what that allows you to do is just browse through your file path and choose the directory that you want to see. So what we're going to do is pull in what this, so in the bottom right-hand side of your screen, you'll see all your available files in the directory that you've chosen. You can select a file from there, or you can call a file in using your code base. And here we're going to read Excel. So here we're using this package, read Excel. And in this package, they have a piece of code called read Excel. So instead of having to do a lot of base coding on creating a data frame, you have one built in already. So we're going to call in university salaries. And now up in our environment, we have 269 observations of 8 variables as a piece of data. There are a couple of things that you can do directly in R that is kind of used as a glossary. So we can do things like view is a function within R. We can get a description of what view is. So this is a definition of exactly what that function does. We can also find examples. For view is not a good example of examples because view has no examples available. But if you have other functions that you want to see examples of that code, you can just type example and that piece of code, and it'll give you examples that are listed within the system. So finally, we're actually going to use this function to view our salaries data. So if we go to view salaries, that now shows us the data frame of our Excel spreadsheet that we just loaded into the system. So this has 269 universities listed with 8 variables, and the variables are listed across the top. This is handy for when you make changes to your data frame. So as you add columns or change names, you can quickly jump over to salaries or to whatever your data frame is, and your data frame will always update. So the view updates as you use it. So you'll be able to see the most updated pieces of the data frame itself. So the next thing we're going to do is we're going to identify our data frame. This is basic statistics and basic analysis. We aren't going to do any manipulation of the data. We're just going to look at it. So what we can do first is we can look at the structure of our data frame. And what this does is it gives us the, it tells us the type of data frame it is. It gives us all of the variable names. It tells us the data type of that variable. It tells us how many values that variable has. So here we're lucky. We have nice, neat data. There are no nulls within our data frame. However, we all know that there are often so many nulls within any given data set. So you can see exactly how many values are within that data set based on the system. I will caveat that with, obviously, we're seeing NAs here. In a minute, I will show you an example of how to replace. These are clearly strings, so they're blank cells that have been interpreted as strings. I'm going to show you in a second how to replace those with true null values to do better analysis on your data frame. And then it just shows you the first few values within that column of the data frame. So the next thing we can do is have a summary of salaries. And what that gives you is a quick summary of every variable. So the length, the class, and the mode. And then for numeric variables, you can get the quartiles. The next thing we're going to do is get the dimensions of this. So we've seen the dimensions up here, but you can run dimensions through your code base as well. So now we know that it's 269 rows by 8 columns. We can look at the length, which we know is 8, but we can specifically call out. And then we can look at the names. And so that gives us specifically the names of the variables within the system. This is always really interesting, and I chose this data set partially for this reason. Notice that after school name and school type, there are a number of blank spaces. This can be really frustrating when you're doing analysis to call that column header because you have all these spaces at the end. So I would advise always looking at what the names of your column headers are, and then before you do any significant analysis on that column, rename it because it makes everyone's life easier, and especially yours. Okay, so next we're gonna do this recreation or replacement of NAs. So what this does is it takes the string that we see here, NA, and replaces it with a true NA, or a true null value. So if we run that, and then we can run our structure again, and we can see these are still 1 through 269, but we are getting true NAs within here instead of the string N-A. Any questions on those before we move on to analysis? Okay, cool. Okay, so the next couple of things that we're going to do are both, structured analysis and then visual analysis. We're going to visualize our data and get an idea of what it looks like so that we can start to do analysis on our end use case. So first we're going to run our quantiles. We saw those a bit up at the head. One reason for using quantile as opposed to the summary that we saw here is that by using the quantile, if you would like, you can change the percentage of the quantiles. So true quantiles are split into 5. You can effectively change it to percentiles and change your percentiles to how you would like to see the data broken out and structured. Here we're going to keep it basic though, and we can run our quantiles on our starting median salary for our universities. And so we get a quick output right here. We're going to run a quick plot on that. And you'll notice that we get a little plot over here. So you can click between your files, your plots, your packages, help, and viewer in this bottom right-hand quadrant here. And this is a really quick and easy chart that we can pull out. And this shows all of the universities that have a listed starting median salary, and then what that median salary is. We can see there's some significant bucketing of this here. And we can start to get an idea for what the pattern of this data is. So the next thing we're going to do is we're going to do the same thing but we're going to use a box plot to do this. So then we can quickly run a box plot on this, and we can see that we have some significant outliers. But we also, we have a fairly well-distributed set of data with a median that is easily and well-distributed between our minimum and our maximum, while also keeping in mind these outliers up top. So visualizations, I love to use them at the outset of a project to really get an idea of and a feel for the data, just to understand how it lays out against one another. So the final thing we're going to do is we're going to use Ggplot to build a more comprehensive chart. Ggplot is used extensively because of how customizable it is. This is a pretty basic customized chart within Ggplot. Because we do have some extra time, what I'll do after this is, as you all are asking questions, I'll grab a few examples of more intense Ggplot just quickly from Google Images and show you all just what intense things can be done with Ggplot. But here we're going to do something pretty simple. So we're going to create a point plot out of salaries. We're going to use for our plot, for our X value, we're using the starting median salary. Ooh. I lost a piece of code. Okay, so, oh, no, I didn't. I just didn't run it. So, apologies. So here we're going to do the thing that I mentioned earlier, which is we're going to rename a column. So this is the really basic way with our base value package to rename a column. So we're going to call names. This is our data frame of salaries. We're going to look at the column in position 2. I'm using the position of the column as opposed to the column name, specifically because the column name for this column is problematic, and that's why we're renaming it. What you can do, though, is you can go directly to your viewer, and you can see school type is the second column. A few weeks ago, we worked in Python. Python runs on a 0 base index. R runs on a 1 based index. So as you're switching between Python and R, keep that in mind, because where school type is index 2 in R, in Python it would have been index 1. So keep in mind your indexes or indices as you go through these. So we're going to rename that column. And then when we go back to salaries, we should see that our heading has changed here from school type capital nice formatting to lowercase uppercase. Okay, so back to our chart. So we're going to use the placeholder of 0.1 for our data frame salaries. What this is saying is we're using the data frame salaries, and with the data frame salaries, we are going to, and then these indents indicate to the code base that these are all the things you're going to do with salaries. So with salaries, we're going to create a plot of X equals starting median salary, Y equals school type. And we're going to create a point on that plot with a fill whose color is this, with a color of that. So the difference between that is the fill is the inside and the color is the outline of the point. And then your alpha is the size of the point. So as we change the alpha, the size of your point in the plot will change. And then we're going to put a title on our plot, starting median salary. So we can run this all together. And you'll see that this comes up in your environment as a list of 9. And what that looks like is this. So this claims that it is a list of 9, but what it means is that it's a list of 9 features and functions within R itself that is coming together and creating this plot. So finally, what we're going to do is we are going to run our new plot. And now we have a plot of the starting median salary for all of the schools that we have listed within our data set by the school type. So we can see things like, well, the majority of our data is coming from state schools, but they also all kind of lump around each other as far as starting median salary goes. Ivy Leagues, however, even though we have so few of them listed in here, they do have a significantly higher starting salary. It's interesting here, we can see that engineering schools have a pretty disparate starting salary, and we could potentially dig into this to understand why these 3 starting salaries are higher than the salaries down here for these schools. So working through these visualizations gives you an idea of, within the initial analysis of your data, where the story starts to form. So you can start digging into areas, you can get a feel for your data, and you can really start to understand where the interesting pieces of your data lie. This is my tutorial for R today. I hope you all really enjoyed it. Does anyone have any questions? You're very welcome. Okay, if there aren't any questions, what I'm going to do is I'm going to quickly share my screen again. When is the next meeting? Our next meeting is January 4th. So this is the last meeting of the year. January 4th, Ashley will be giving a tutorial on data cleaning, both in R and in Python. So quickly, I'm going to give you all an idea of just the kind of things you can do in Ggplot. So this is a, Ggplot 2 quick Google search, but some of the really interesting things you can do is create different colors and trend lines based on the different breakouts of your data. So the different variables that you're identifying your data as. You can create data as a dashboard as opposed to just an individual chart. You can create really cool color charts that also have keys on them, which you always want a good key on your chart if you're going to make it a little complex. You can do really cool charts. This is a little small, but you can do multivariate charts that allow you to identify the pathways between different variables and the connections between them. So yeah, there are just really an unending possibilities with what is available with Ggplot and R in general as far as visualizations go. Okay, well, if there aren't any questions, thank you all for joining. We will be back here on January 4th again at 7 p.m. To learn more about data cleaning in R and Python. I hope you can all join us then, and I hope everyone has a happy holiday.
Thanks, everyone.